All right, here we are on the Lesson 2 practice problems, Algebra 1, Illustrative Mathematics. This starts on page 144 of your student workbook. There's only 6 or 7 problems today. Let's go look. 7 problems, and that last one is a review back from our previous unit on solving systems. So let's see how we do today. The height of the water in the bathtub is a function of time t. Let p represent this function, and the height is measured in inches and time in minutes. All we're doing on this one is a matching of statements. So using this new function notation, p of 0 equals 0, p of 4 equals 10, p of 10 equals 4, p of 20 equals 0. Which one goes with which words? Pause the video right now and try matching it and see how you do. All right. After 20 minutes, the bathtub is empty. You got it. Did you match it to this one? So do you want to write 1D or D1? Remember on IL Classroom, you're going to go ahead and slide and drag those. The bathtub starts out with no water. You got it. 2 is A is 2, or drag on digital IL Classroom. After 10 minutes, the height of the water is 4. 3 is C. And the height of the water is 10 inches after 4 minutes. How'd you do? Function C takes time for input and giving a student's Monday class for its output. Use function notation to represent a student has English at 10. Let me switch over to text really quick so you can see it a little bit easier. So the input is 10 o'clock and the output is English. A student has English class at 10 a.m. Now write a statement to describe the meaning C of 11:15 equals chemistry. How'd you do? Next, the function gives the distance of a dog from a post in feet, just like we did during the lesson. Can you find the value of f of 20 and f of 140? Please pause the video and go try it. All right, let's see how you did. F of 20, what would you call that output? It's going to be a decimal, right? Do you want to call it like it's just past 3? And then f of 140 is way over here. Follow it up. What would you call that? I don't know, 3.5, something like that, as the output. So again, where am I getting that number? I'm following it over here to look where is it falling on the y-axis. Function C gives the cost in dollars of buying n apples. What does each expression represent in this situation? Let me switch back over to text. So we could say something like 5 apples, that's my input, costs $4.50. And what do you think for C of 2? You got it, the cost of 2 apples. All right, a number of identical cups are stacked up. The number of cups in each stack and the height of the stack are related. Can we say that the height of the stack is a function of the number of cups in the stack? Explain your reasoning. Yes, for every number of cups, there is one height, right? Can you picture it? Adding 1 cup, the height goes up. Adding another cup, the height goes up. So can we say that the height is a function? Yes, for every input, there's only one output. Can we say that the number of cups in a stack is a function of the height? Yes, for every height, in centimeters, there is only one number of cups. So it can go both ways. It can go cups and height, height and cups. It's a function either way. All right, let's do a sample graph here of this situation. The number of cups based on the height. Sketch a possible function. So what do you want to do? Height on the bottom in centimeters. Do you want to count? I don't know. Let's count by twos maybe. And this down here is going to be your height in centimeters. And along the side, you've got that number of cups. How do you want to count? Again, want to just go by twos. And then just go put some possible scenarios. So 6 centimeters was 1 cup. And then we're going up each cup by 1 centimeter. Why is this not a connected line? Because we're adding a cup and then there's a new height. This is not something continuous like water, that's flowing and constantly going, or time that's continuously going. This is just adding a cup and a new height. So this is, do you guys remember the name for this? It's a discrete function where it's just dots, where it's not connected. All right. Finally, this is a review from last unit. Do you remember these? You've got to make opposites in order to solve by elimination. So pause the video and try A and B. See how far you can get. See if you still remember how to do this. Okay, let's see how you did. So the top one has a negative and the bottom one has a positive. In the next one, the top one has a positive and a negative. So you can decide to go for the X's and the Y's easily. I'm just going to go for the X's. If I multiply the top by 3 and the bottom by 5, just using the other numbers, let's see what we get. New row. Careful with all your negatives. And bottom row. So remember how we would look ahead and think, is this going to have one solution, many solutions, or no solutions? Does both the X's and Y's cross out, or is it just one variable? Well, since only one variable is crossing out here, this is definitely a one solution problem. So we've got to subtract 35 and 9. Because they were different signs. Over here, we're going to add because they're the same signs. And let me just check to see that really they gave us one with that bad of, yep, it's a decimal. So let me grab my calculator and see what this decimal comes out to. Oh, good. It's only 1.5. It just looks nasty. And then now that I got half my answer, the y value, I need to plug back in and get the x. You can use any equation to plug back into. So I'm plugging in for y. So this answer that I just got right here for y is plugging in for y on the substitution. So 7 times 1.5 is 10.5. You're going to add that to both sides. How are you doing with this? Is this coming back to you? 10.5 minus 3 is 2.5. So I've got my x, I've got my y, and I'm going to go put that answer together. 2.5 comma 1.5 is the solution to my system. The solution to the system is the point of intersection. We got a one solution. Okay, if that one was like a refresher for you, pause the video, go try the second one. Let's see how you do. Okay, I'm going to multiply the top row by 5, the bottom row by 8. And I need a calculator for that one. How about you? 24 times 5 getting 120. So now, is this one solution, no solution, or many solutions? Well, only the x's cross out. So again, we're heading towards a one solution of a system. So 120 plus 16 was 136. 136 divided by 34, we get -4. That's half my answer. Let's go plug back in to either equation. I choose the bottom one. It looks a little bit smaller numbers. Plugging in that y was -4. Negative times negative is positive. 5x equals -10. Divide by 5, divide by 5. I've got my x, I've got my y, put them together. The solution to the system is the point of intersection. How'd you do? We can't forget these systems from last unit. Let's keep practicing.